Hello everyone, today we're going to look at compound interest. So we're going to be using the following formula. It looks like two different formulas, but they are the same thing. So it's S equals P times 1 plus I to the N, or S equals P times 1 plus R over M to the MT. So I is just R divided by M, and N is just MT. So it's the same equation, and we're going to think really of T like our variable, so this is an exponential. So it's really continuing from before. So these are what the letters represent. S is the future or the compound amount. So basically you're thinking of putting money into a bank and getting interest. So S is the amount after the interest has been applied. P is the present amount, also called the principal. It's how much you deposit into the bank account. R is the interest rate as a decimal. So you're going to be given it as a percentage. Make sure you change it to a decimal, which just means moving the decimal point 2 places to the left. M is the number of times per year interest is compounded. T is the number of years, and then as I mentioned before, I is just R over M, and N is MT. So I want you to have this formula written down because we're going to refer back to it, and I want to make sure that you have it on hand. So I would write this down somewhere. So answer the following questions. If $5,000 is invested for 6 years at 4% compounded weekly, how much is in the account after the 7 years? So we need to figure out what numbers go in for what letter. So we're looking for how much is in the account later in the future, so that's the future amount. So we're looking for S. The $5,000 is what's being invested, so that's the principal, that's the present amount, that's P. The interest rate is 4%. 4% as a decimal is 0.04, so that's R. M is how many times it's compounded in a year. So it's compounded weekly, and how many weeks are in a year? 52. And then we have the time, and I'm realizing right now that I have two different time frames on here. This 6 should also be a 7, so those should both be the same 7. And T is 7. So we're just going to ignore that 6 there. So then we plug it into our equation. S equals P times 1 plus R over M to the MT. Notice that M is the only number used twice, so make sure that you have it in there twice. Now at this point, it's a calculator problem. Can you plug this into your calculator correctly? If your calculator can plug in more than one step at once, then you can plug it in directly as you see it, except you need an extra parentheses to your MT because you need to do that multiplication before you raise it to the power. So if you're going to do it all at once, just include that parenthesis there. If you're going to do it step by step, don't forget order of operations. You're going to do the parentheses first, then the exponent, then multiply. If you do it correctly, you should get $6,614.94. I want you to make sure you're actually doing this to see that you know how to use your calculator and that you're getting the same answer. So please do this out. How much will $1,500 at 3% compounded monthly be worth after 5 years? So I'm going to go through the process. It is asking for how much it will be after the 5 years, how much it will be in the future amount, that's S. The $1,500 is what we're investing, that's the principal, that's the present value, P. Next is your interest rate, 3% as a decimal, 0.03. And then M, compounded monthly. How many months are in a year? 12. And then the last thing is T, how many years? 5. So again, I'll plug it into our equation, 1,500 times 1 plus 0.03 over 12 to the 12 times 5. What's really important in these, and I should have mentioned it in part A, is that you cannot round in the middle. Okay, especially something like 0.04 to the 52, you cannot round that at all. make sure you're using that whole thing in your calculator. You really want to make sure that you're using the answer button if you're going to do this piece by piece. Or like I said earlier, do it all at once. Just make sure order of operations is maintained and you have parentheses around your exponent. Okay, but there's absolutely zero rounding in the middle of the problems. You only round at the very, very, very end because it's money and money has 2 decimals. Okay, so if we do out part B, we should be getting $1,742.43. So now that we've done 2 of them, what you should notice is that whatever it is you're investing, that's going to be less than what you get out at the end, right? You're making interest, so your S should always be more than your P. Another thing to notice is that the interest is just the difference between the two. So the interest is S minus P. So if I wanted to know, say in part B, how much of this money was interest, that's S. I'm going to subtract P, which was $1,500. So the interest would be $242. It doesn't want to do my period, and 43 cents. Okay, so it's just the difference between the two is your interest. How much should be invested now if you want $6,000 after 10 years if the money is invested at 7% quarterly? So now the question is, how much should we invest? So I'm not looking for S, I'm looking for P. And S is the 6,000. I want 6,000 after, I want 6,000 in the future, that's S. And again, I don't know P. Or 7% as a decimal, 0.07. M, it's compounded quarterly. How many quarters are in a year? Well, that's kind of a trick question. There are 4 quarters in any whole thing, so there are 4 quarters in a year. So M must be 4. And then it's 10 years, so T is 10. So now the question is, if I don't know P and I know S, how do I solve for P? So what I do is I have my original equation, which was S equals P times something to a power. I don't really care what's in those parentheses. I don't really care what's in the power at the moment. It's S equals P times something to the power. I want P by itself, so I'm going to divide by everything else. And so I could write this as P equals S over 1 plus R over M to the MT, but using rules of exponents, I can take something to a power and bring it up by making that power negative. And that's where this negative sign is coming from. So I've switched my S and P and I've made the exponent negative. The thing that most people get wrong, if they do get this problem wrong, is they forget the negative in the exponent. It's really, really important that that negative is in there when I'm solving for P. That's going to make my P smaller than my S. So I'm going to plug the numbers in. 6,000 times 1 plus 0.07 to the 4 over 4 to the negative 4 times 10. Again, make sure you're careful about how you plug it into your calculator. And again, this number P better be smaller than your S. And you should be getting $2,997.61. Sue wants to save up $4,500 by investing some amount of money now for 3 years at 5.5% interest compounded monthly. How much should she invest? So again, I'm looking for how much she should invest. I'm looking for P. She wants to have this amount in the future, so that must be S. I'm looking for P. Or 5.5%, move the decimal twice, that's 0.055. Compounded monthly, again, there are 12 months in a year. So M is 12, 3 years, T is 3. Again, I want P, so I'm going to use that equation where I've switched P and S and made the exponent negative. Plug it into your calculator, and you should be getting $3,816.96. And again, I could ask, what's the interest? So the interest is S minus P, which is 4,500 minus 3,816.96. And so for interest, Sue made $683.04. Okay. The more often you compound interest, the more money you'll get at the end. And the most compounding you can do is something called compound continuously. And that's just what it sounds like. So that should be what? You're constantly compounding the interest, putting it into your principal to get more interest. However, the question then becomes, what is M? Well, if I'm compounding continuously, then M in theory would be infinity. But that's not possible in an equation. So what we do is we look at the limit as M gets bigger and bigger and bigger and bigger. What happens to our equation as M goes off to infinity? So that's a little more behind the scenes calculus type question. So we're going to not go through the background for it, but you're just going to trust me on this, or you can Google it if you want. But if M goes to infinity, we're compounding continuously, then we get the following equations. S equals PE to the RT, and P equals SE to the negative RT. So as soon as you see compound continuously, we're going to use these equations. If you notice that E is Euler's number, it's popping up again. And we're going to see it in action in the following examples. So how much will you have after 6 years if you have $900 compounded continuously at 6%? So how much will you have? That's S. What's the future? 6 years is T. You have 900. That's the present value. Compounded continuously, that means I'm going to be using E. 6% means R is 0.06. So we're going to plug it into this equation. And we get S equals 900E to the 0.06 times 6. Again, be careful. Make sure you put that in parentheses. You're doing that multiplication before you do it as an exponent. If you do it out correctly, you should be getting $1,290.00 rounded. How much do you need to invest today if you want $400 after 2 years? If the money is invested at 3.25, that's supposed to be a percent symbol, compounded continuously. I don't know why there are 2 question marks there. So how much do you need to invest today? That's the present amount. That's what you're looking for. You want $400 at the end. That's the future amount. After 2 years, that's T. My R is 0.0325. Again, move the decimal twice. Compounded continuously means we're going to be using E. So again, we've got this negative exponent here because we know S and we're looking for P. And if you do it correctly, you should be getting $372.96. Again, P has to be less than S. How much will you have after 20 years if you invest $100 at 10% compounded continuously? How much will you have after 20 years? That's the future amount. 20 years is the T. What you invest is P. 10%, that means R equals 0.1. You could do 0.10. It's the same thing. Compounded continuously means E. So we plug it in. S equals 100, E to the 0.10 times 20. You should be getting $738.91. Again, S is bigger than P, so it makes sense. And for our last one, how much do you need to invest now if you want $25,000 After 10 years, if the money is invested at, again, that's supposed to be a percent symbol, at 5% compounded continuously. How much do you need to invest now? That's P. So we're going to be using the negative exponent like we did up here. You want 25,000. That's the future amount. T is the 10. It's a little messy. T is the 10. 5%, 0.05. Compounded continuously tells me E. So P equals 25,000, E to the negative 0.05 times 10. And that should be giving $15,163.27. And again, P is less than S, so it makes sense. If I wanted the interest, again, I would subtract the two. So I'd take 25,000, subtract $15,163.27. And I'll be getting $9,836.73. Okay, so make sure you read through the book and try out the homework problems, and let me know if you have any questions. Thanks.